Sedimentation refers to the process where heavier particles settle at the bottom of liquid due to the gravity. This technique is commonly used to separate mixture based on differences in particle density and size. In the mixture of chalk powder and sand suspended in water, sand being coarser and denser settles more rapidly. Chalk powder composed of finer particles remains suspended for a longer duration and may even form a floating layer or cloudy suspension. When sedimentation occurs, decantation is used to separate a clear liquid from the settled particles. The liquid at the top, known as supernatant, is carefully poured off, leaving the sedimentation at the bottom. Next, moving on a jet-sieving principle that separates particles by size using a string or air. Fine particles are pulled through a mesh, while larger ones stay on top, allowing fast and precise aspiration. The objective of this experiment is to evaluate the separation efficiency of a chalk powder and sand mixture using sedimentation and decantation, and to observe how particle size and density affect the process outcome. To begin the experiment, 15 grams of chalk powder and 50 grams of sand were accurately weighed and recorded. Sand and chalk powder were mixed using stirring rod to ensure a homogeneous mixture. Both were thoroughly mixed in 100 ml beaker using a stirring rod. Then 100 ml of distilled water was added and the mixture was stirred vigorously for 1 minute to create a uniform suspension. The beaker was placed on a stable surface and a stopwatch was started. Next is decantation was performed. The upper chalk-rich liquid was carefully poured into a clean beaker without disturbing the sand. About 10 ml of distilled water was added to the sand, gently swirled and allowed to settle for 5 minutes. This washed water was also decanted into the same beaker. The washing step was repeated. To recover the chalk powder, a vacuum pump was used to filter the chalk suspension through the pre-weighed filter paper. The filter paper was then dried in oven at 80°C until a constant mass was achieved. The sand was transferred onto a separate filter paper and dried at 105°C. Once dry, both filter paper were weighed and final mass of sand and chalk powder were calculated and recorded for analysis. Beyond manual technique, modern methods like air jet sieving are employed for more efficient separation. This method separates particles based on size and aerodynamic behavior. A vacuum pump generates downward airflow through a sieve, while rotating nozzle disperses the sample evenly and prevents clogging. Fine particles such as chalk powder are pulled through the sieve, whereas the coarse particles like sand remain on top. This technique provides improved precision, speed, and particle recovery, especially when handling fine powders in industrial or laboratory environments. Results indicate that a portion of chalk powder was lost during decantation. This may have occurred because of the fine chalk particles remain suspended in the liquid and were unintentionally destroyed during pouring. Additionally, some drop of moisture may have adhered to the sand particles, indicating incomplete separation. This outcome highlights the limitation of manual technique, especially when fine and coarse particles are present in the same mixture. This table compares the manual method with high-end instrumental method. Manual techniques offer low to moderate accuracy, are time-consuming, and require multiple steps, but are cost-effective and easy to use. In contrast, high-end instruments offer high accuracy and faster separation using control systems like centrifuge or air jet sieving, but they are expensive and require trained personnel. So both methods have their strength. Manual methods are low cost, easy to perform, ideal for small scale tasks and don't require electricity. On the other hand, high-end instruments provide high accuracy, faster acceleration, more consistent result and better recovery of materials, making them ideal for industrial and research use. Despite their usefulness, each method has limitations. Manual methods are time-consuming, prone to human error, and often produce inconsistent results. Meanwhile, high-end instruments are expensive, rely on a power supply, require skilled operation, and may not be accessible in all lab or locations. In industry, sedimentation and decantation are frequently applied in wastewater treatment and mineral extraction to remove solid contaminants from liquids. However, for finer particles or when high precision is required, techniques like jet sieving or centrifugation are preferred. This method ensures efficient, accurate exploration, making them essential in large-scale operations where the quality control and productivity are critical. In conclusion, sedimentation and decantation provide a practical and cost-effective method for separating mixture like chalk powder and sand. This technique is suitable for basic density-based separation and is widely used in educational and field applications. However, it presents limitations such as particle loss, reduced accuracy, and longer processing time, especially for fine particles like chalk. Advanced techniques like jet sieving offer significant improvement in recovery rate, separation speed, and precision, making them preferable for industrial and research purposes. Ultimately, the choice of separation technique should be aligned with application requirements in terms of scale, material type, and desired outcome accuracy.